Good morning, everyone. Welcome back to Algebra 2 with Pre-Calculus. I'm Mr. Malcolm. I will be guiding you through today's Think About It. Now, please take the next 90 seconds to place your notebook, your laptop, graphing calculator, and pencil on your desk. Add today's lesson, which is lesson 10.02. And today's title, which is Theoretical Probability and Single Events, and date to the next empty page in your math book. Today's date is May the 12th, 2020. Today's actually my nephew's birthday. So happy birthday, nephew. Hope you live to see many more. Right? Moving on into our lesson for today. The aim for today is, given a simple event, students will be able to calculate the theoretical probability of the event occurring. Students will be able to distinguish between theoretical and experimental probabilities and explain why they differ. Okay? We'll get right into that as we go through today's lesson. So a coin is flipped 3 times in a row. What is the sample space? Okay? So from yesterday, a sample space is the total amount of possibilities that there can be. So a coin has two sides, heads and a tail. Now, if the coin was flipped 3 times in a row, you can get a certain amount of probabilities. Now, the easiest way to do this, or the most non-complex way, for those who can't see it, is to just write out what the possibilities could be. So there is a possibility that you could get heads, heads, heads. That's one possibility for all 3. I know that's not a common thing, but you could also get heads, heads, tail. You could get heads, tail, heads. You could get tail, heads, heads. Okay. You could now get tail, heads, tail. You could now get tail, tail, heads. And you can also get tail, tail, tail. 1, 2, 3, 4, 5, 6, 7. There's one more missing. Oh, and you could get heads, tail, tail. Yep, I think that's about everything. Okay? So these are all of the possibilities. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 possibilities that you could get. Okay? Now, another way, this is option number 1. Okay? Option 2. A coin has 2 faces, and they're going to be done, there's going to be 3 events. So all you would need to do is put 2 to the 3rd power. The power represents the amount of events of this happening. So that would be 2 times 2 times 2, which would give you 8. 2 times 2 is 4, 4 times 2 is 8. Okay? So you have 2 ways of getting your sample space. Okay? So that's for part A. Part B, the probability that all 3 of the coins will land on heads is 1 out of 8, as we discovered before. So this is the part that they're talking about. Okay, 1 out of 8. Use your sample space from question 1 above to explain why this is the case. Is the event really likely or relatively unlikely? Okay, so dealing with the first part, why is it 1 out of 8? Because if you wrote them out, you would notice that there's only one chance in all 8 different possibilities that would give you a heads 3 times in a row. So that's 1/8 of a chance to get all heads 3 times in a row. Okay. Now, is it likely? Would you gamble on 1/8 of a chance? Some people will, but relatively, it's not likely. Okay, that you'll get 3 heads in a row. If it's a fair coin, now obviously there's coins that are not fair and they're geared towards landing heads every time or tails every time or whatever it's geared towards. Okay. Part C, a probability of 1/8 also means that 1 out of every 8 times they are flipped, all 3 coins should land on heads. If you were to flip 3 coins 8 times and record the outcomes of each flip, would you expect all 3 coins to land on heads exactly once? And the answer to that comes from figuring out theoretical versus experimental. Okay? Theoretical, in theory, you should end up with 1 out of 8. But when you do this in reality, you could end up with anything. In reality, based on which side you put on your finger first, or all different things, the wind, how it lands, all kinds of stuff, you could end up with 8 out of 8, or it could be 2 out of 8, or it could be 3 out of 8. In reality, the experimental doesn't follow the theoretical 100%. This is because this is a probability. Okay, this is probability. Probability doesn't mean that it will happen 100% of the time. It just means that it's probable. There's a chance that it will happen that way. In theory, it should be 1 out of 8, but experimentally, it could be anything. However, if your experimental design is big enough, and well structured, you will notice that you will end up with something closer to 1/8, depending on how big your sample is. So if you get a massive sample, let's say you didn't do it just 8 times, you did it 8 million times, then your experimental might come a little bit closer to the theoretical of 1 out of 8. But it just depends on how well your experiment is designed. So that is the difference between theoretical and experimental. So in theory, you should end up with 1/8, as I said before, but in real life, when you do this as an experiment, you could end up with any kind of fraction. Okay, so that's all we have time for today. Please make sure that you show up to class on time and that you're ready to go. All right, have a great day. Enjoy. Bye-bye.